All right, so you have Chapter 2, or test tomorrow. Chapter 2 test. So it's been a little while since we've done all these things from the first lesson. Now, let's look at something like this. You're going to have to find limits. And you're going to do limits a few ways. You're going to do them by graphing, and you're also going to have some algebraic limits to do. So algebraically. So let's look at a graph real quick, and let's just try to review what limits are, okay? So suppose I have this graph, and 1, 2, 3, 1, 2. Let's say I have an open circle here, and there's like maybe a sideways parabola, and then something that looks like that, okay? All right, and I'm going to, and let's do this. Let's put a dot right here just to really mess with you. There we go. So let's go ahead and we're going to find the limit of three things. We're going to find the limit as x goes to 3 from the right of this function. We'll call it f of x. We're going to find the limit as x goes to 3 from the left. We're going to find the limit as x goes to 3. And then we're also going to evaluate f of 3. I don't know. Okay, so here we go. So now let's go ahead and go from the right, and let's find out what the limit is. So I'm looking at this first one, 3 plus. Here's 3. The plus side of 3 is going this way, and so the limit is, anybody? 2. It's 2. It's getting closer and closer as we go towards 3 from the right. We're getting closer and closer to 2. How about 3 from the left now? 3 from the left, I'm getting closer and closer to the y value of 2. 2 again. Looks like a ghost 2. Okay, now because those two are equal to each other, then that means the limit at 3 equals 2. Well, if they were different from one another, remember, the limit does not exist. Yeah?
The only time the limit doesn't exist is when you have two that are different and then you try to combine them.
Yeah. Yeah. Okay, and then what about f of 3? If I plug in 3 into this function, what y value is the output? 4. Perfect. It's way up here. It's 4. Now, is this a continuous function? No. It's not continuous. Continuous. So I might ask you that on the test. Is this continuous, yes or no? You would say no, and then your reasoning why is because it has a hole in the graph. Yeah, it has a removable point. Because in order to be continuous, you have to have 3 things. The limit has to exist. Okay. What else? The limit and the function value have to be the same. And there was another thing. I forget it now. Okay. I guess it's not important. Okay, so that's a graphically one. What's going on in here? Are we sending pictures around? Hayden's cracking up. He's containing it, which is nice. Okay, so that's graphically. Now let's do some algebra ones. It's not, though. I have lots of videos. You can watch them. All right, let's do some algebra. So let's go ahead and do something, kind of easy. Let's find the limit as x goes to 6 for x minus 6 over x squared minus 36. Okay. Now I'm going to get a couple of you. I hope I don't, but people, what they'll do is they'll go, okay, limit as x goes to 6. I'm going to plug it in. I get 0, 0. Limit does not exist. Wrong. Yeah, that's wrong. Okay? Guess what you're going to do? You're going to take these algebra skills that you learned, and you are going to do some algebra here. So, in algebra, we learned how to factor. We learned how to factor quadratics. And so this is the difference of 2 perfect squares. And so we're going to factor this as x plus 6 and x minus 6. And what happens is these will reduce. And so now you're actually evaluating the limit as x goes to 6 of 1 over x plus 6. Now, is there any problem? No. We got rid of the problem. The problem was 0 over 0 right here. When I plug 6 in, my answer is 1 over 12, and that's the limit. Okay? This is, it's a hole in the graph, basically, is what it is, when you graph this thing at -6. It's this easy.
Really?
Yeah. Let's do another one, algebraically.
There's no limits, right? Like graphs, just take those out.
No, there's limits on graphs. How about the limit as x goes to 3 for the square root of x plus 9 minus 3. Oh, wait. Let's do the limit as x goes to 0. Change it up a little bit. All over x. Yeah, there we go. Perfect. Okay, so once again, let's... Are we airdropping? All right, once again, let's go ahead, try to plug in 0, and what happens is you will get 0 over 0, okay? And that's a problem. Doesn't mean the limit doesn't exist. It means you have to think of some algebra methods to do so you can get the answer. So let's go ahead. Does anyone have any suggestions on how to solve this?
Ooh.
Perfect. Conjugate. Let's multiply numerator and denominator by x plus 9 plus 3. Okay? Yeah, it's going to make this thing more complicated, but then in the end it's going to work out really great. All right, so here we go. We got the limit as x goes to 0. Go ahead and take the top and FOIL it. So we'll get x plus 9. Inside, outside, because these are conjugates, the O and the I part of the FOIL will cancel out. And then you'll get minus 9. On the bottom, just leave it. Don't distribute that x. You don't want to. Okay, just multiply the conjugates. And so do you have some algebra foreshadowing happening? You do. The 9's cancel, and the x's reduce, leaving us with a 1 up top. Be very careful. When you reduce stuff from the top and everything's gone, it doesn't mean it's nothing. Okay, there's still 1 up there. So now we're going to evaluate the limit as x goes to 0 of 1 over rad x plus 9 plus 3. So that would equal 1/6. 1/6. Very good. Yay, don't you love algebra?
Wait, can you go back a step?
Yeah. Which step?
Where you crossed out the whole top section.
Yeah. So what I did first was I had a plus 9 and a minus 9. So those subtracted. And then you have an x up top and a factor of an x on the bottom, so those will reduce.
Okay.
Yeah. Okay, we're just going along. We love this. Here we go. Ooh, yeah. Let's do one of these now. All right, so the next one's going to be just like those kind that were on your quiz, that second quiz that we took. So let's say that you have this function. F of x equals x plus 5 over x squared minus x minus 6. Okay? And then I'm going to ask you some things. We're going to find the limit as x goes to infinity of this function. We're going to find the limit as x goes to negative infinity of the function. And then we'll stop right there, and then we'll do some other ones too. There's going to be a whole bunch of them for this. So the first thing you want to do is you want to go to your calculator and you want to graph it. Okay? Now, you can do these without graphing, but I know you guys like to graph them, and that's okay. Bless you. Again. All right, x squared minus x minus 6. Zoom 6. Okay, so the graph, when you graph it on your calculator, it's going to look like that. All right, so if you can't tell where the asymptotes are on your calculator, which you kind of should be able to, you could factor this thing, okay? If you factor the denominator, you will see that you get x minus 3 and x plus 2, which means that I have vertical asymptotes at positive 3 and negative 2, okay? The other asymptote I have is, if I look at this of x over x squared, and I think of that as really 1 over x, then my other asymptote would be 0. Okay? So as x goes to infinity, well, let me graph it. It looks like this, and there's some kind of weird parabola-looking thing down here. Okay? So that's the graph. So as x goes to infinity out this way, what is y getting closer and closer to? 0. Plug infinity in to here. What is 1 over infinity? It's pretty much 0. All right, the other direction, same, 0. Okay, which means that we have a horizontal asymptote at y equals 0. All right, now here are the other questions I'm going to ask you. What is the limit as x goes to 3 from the right? What's the limit as x goes to 3 from the left? Oops, I wrote that in the wrong spot. 3 from the left. Okay, so let's take a look over here at 3. Let's use red this time. So as I'm going towards 3, what's y going, approaching? Infinity, right? Our vertical asymptotes, if I'm approaching a vertical asymptote, I'm either going off to infinity or negative infinity. So on the right side of 3, it's infinity. But what about the left side of 3? Negative infinity. So what can we say at 3? The limit does not exist at 3. Okay? They're not equal. Infinity and negative infinity are not equal. Like, they're the most not equal things ever, actually. Okay, and then I would ask you, what are your vertical asymptotes? And the vertical asymptotes, you can see them on the graph. I graphed them. One's at x equals 3, and the other one is at x equals negative 2. Okay? Here's one. What's the limit as x goes to 0? What would you do there? Well, you just plug it in. As x goes to 0, you plug it in, you get 5 over negative 6. So negative 5/6. You could also go to your calculator and hit trace and plug in 0. You get negative 0.833 repeating, which is negative 5 over 6. All right, you feel pretty good about that one? Yeah? Sure. Sure. Okay, next one. What if I gave you something like f of x equals x plus 9 over x squared plus 10x plus 9. Yeah, I think that'll work. All right, and I'm going to ask you to find the points of discontinuity. Find the points of discontinuity, really the x values. X equals blank, x equals blank. And then I'm going to ask you what type they are. Type of discontinuity. And then if it is a removable discontinuity, then how would we make it continuous there? What would be the y value? What would the y value be to make it continuous? Okay, that only works on removable discontinuities. It doesn't work on jumps. You can't fill that in, that gap there. All right, so the first thing you want to do is you want to factor. So we'll go over here, and the numerator stays the same, and the denominator. What times what's 9 adds up to 10? How about 9 and 1? Okay, 9 and 1. So 2 points of discontinuity, there would be one at x equals negative 9 and one at x equals negative 1. Now, if you want to, you can graph that and see what they look like. But here, this is removed. So guess what it's called? Removable. Removable. Okay? There's no L in removable. Removable. The other one at negative 1, do you know what that's called? There's a vertical asymptote there. Infinite. Perfect. It goes to infinity on either side of negative 1. Okay? And you can graph it if you want to see it that way, but these are pretty normal. All right, now, what would make it the y value continuous at the removable point? So x is negative 9 there. What would y need to be to like fill in the hole there? Okay, there's a hole in the graph, and we want to fill it in. So you know what we do? We go to here where you reduced, which is 1 over x plus 1, and we plug -9 in. Okay, it's almost like taking the limit, right? Or it is. It's exactly like taking the limit at that point. So you get, what would that be? -1/8? -1/8. There it is. All right, doing pretty good. Okay, and then the rest of it is going to be rate of change. So you'll have one that's going to be an average. Just use old school slope. The change in y over the change in x. Okay? And then you're going to have some, instantaneous changes or tangents and all that stuff. So you'll have tangents. I will give you the formula again. So you're going to use the limit as h goes to 0. I think that's all pretty fresh. I don't think we need to do any of those. All over h. Okay, that quiz that we just took that I got back to you, you'll have some of those, tangents, and then there'll be an interesting bonus question. That's it. Okay, that's the whole test.